Class. I am Khushi Gupta of BCA PPU Batch 1 3rd year, and I am here to give a presentation on the topic storage virtualization under the guidance of respected Murli sir. So let us dive into a world of virtualization. So understanding what actually virtualization means: when a physical device is being used to do the job of multiple physical devices, by creating a virtual versions of them. Virtual versions in the sense of we are creating virtual servers or virtual storage or virtual machines. So when we use virtual version of them of different machines on a single machine, then we call it virtualization, and it helps to save money, it helps to use resources better and in an efficient way. Next, I will explain virtualization giving a real world example. Just think of a television which is showing multiple channels. So we have a single television and we can see multiple channels on the same television. So just compare the channels as virtual machines. So we don't need different televisions for seeing different channels. So this is a basic example of how virtualization can create this using the same machine for different channels, for broadcasting different channels which have their own purpose, which are being used for their which shows their own things, and they work separately and they all show on the single TV. Next, we have the types of virtualization. Within virtualization, the types are server virtualization, storage virtualization, network, operating system, application, and desktop virtualization. Next, I will be dealing with storage virtualization. What basically is storage virtualization? When the virtualization is performed on the basis of storage, that is, if we are combining multiple physical disks to create a single large storage which is called a pool, then it is called as storage virtualization. And the basic features of storage virtualization is that it causes abstraction of physical storage into logical storage, because when we are creating a pool, it is a logical storage. It is something which is only visible to the end users, but it does not exist in reality. So there is a hiding of physical storage. That actually means the abstraction part here. Now next is that we are creating a unified version of multiple storage device into a single version. So this is an efficient use of storage system. Next, why we need storage virtualization? What is the need? Why we study storage virtualization? So the basic and the main purpose is that it overcomes fixed limits, because if we are using a single hard disk, then the limit is fixed, the size is fixed, and if we are creating a pool using storage virtualization, it is dynamic, we can resize it. So to overcome the fixed physical limit and use it dynamically, we use storage virtualization. Next, storage evolution. How the storage has evolved from DAS, which is direct access storage, the time when we used to use punch cards, CD-ROMs, etc. for storage, for extra storage, to NAS, which is network access storage. Next comes storage area networks, which is data centers created for storing data. The next comes storage virtualization, and now everything is switched to cloud, which is basically SDS, that is storage defined software defined storage. Next, we have the types of storage virtualization. So storage can be virtualized based on three types. We have, the first one is block level, second is file level, and the third is object oriented or object level. Now I will explain storage virtualization based on a real world analogy. Just think of a smart plumbing system as shown here. We have multiple tanks, physical tanks, and they are all connected with pipes, and there is one control system as here. So this control system is required to connect all the physical disks, the tank. The big tanks here are the physical hard disk, and these pipes used to connect them are the techniques like RAID, ISCSI, or stripping or mirror, etc. And this is a pool which is created as a result of the entire system which is in the backend or behind the scenes. So the end user just uses this pool, which is a virtual pool and not exist in reality. So this is a smart plumbing system, and it controls how the data can be accessed and how the data is managed and stored, and everything is behind the scenes and not seen by the user. This is what storage virtualization is. Now, what is the result was that of that smart plumbing system? The result is that you don't see what is going behind the scenes. The end user just use this small pool, a clean storage space which is provided to the user, and they don't care how their data is being stored, how the data is managed. They are just using this pool which is offered to them. The next is that I have already mentioned that you are using a clean storage space, and behind the scenes what is going on, what is the control system doing, how the big tanks are connected and which pipe is being used for connecting them, the end users don't care. So why is it useful? Because it is easier to manage, it can grow or shrink, that is it is dynamic in nature, and it is more reliable, and it is a smarter technique for storing our data. The next we will study techniques of storage virtualization. Techniques basically means the only answer is that the pipes that we use for connecting the physical tanks over there, that is the smarter ways how the physical disks will be connected to create a single large storage are the techniques. So the smart ways or the tools or the pipes in my example to control how our data is stored, how our data is protected, how it is accessed, and how it is managed, the 4 keywords. So this is what techniques means, and within the techniques we have 5 important techniques, that is RAID, LVM, the third is ISCSI, fourth is mirror, and the fifth is stripping. Knowing them one by one, first is RAID. RAID stands for Redundant Array of Independent Disks. That is when we are connecting the physical disk to create a single large storage. And why it is done? It is done to improve the performance, for the fault tolerance, and we have a speed to access the data, and there is a backup of data based on which level of RAID we are using. Now, level of RAID, within the levels we have 5 level of RAID. RAID 0, RAID 1, RAID 5 and 6, and RAID 10. RAID 0 basically means that we are only splitting our data across multiple disks. So we have a faster access of data, but there is no safety to the data because there is no backup of data. Within RAID 1, which is basically mirror technique. Mirror technique creates a duplicacy of data, that is our data is duplicated into another hard disk. So it provides faster access of data as well as a safety to the data because our data has a backup. If any disk fails, we can recover our data. RAID 5 and 6 are stripping techniques. It splits our data across multiple disks and it splits according to parity. Parity actually means that some information of the data is stored to recover the data in case the disk fails. So based on whether we are using single parity or double parity, we have RAID 5 and RAID 6. Then the last one is RAID 10, which is a combination of the features of RAID 0 and RAID 1. In this case, we have both the faster access of data as well as a backup recovery of data, but it is applicable only when we have at least 4 disks. Next is LVM. LVM stands for Logical Volume Manager. So it is basically when we have combined the physical disk and when we have created a pool. So how we are using that pool, how we are resizing it by splitting or any smarter. So smarter technique which we are using to store our data in the pool is LVM, and it is basically used in dynamic environments like Linux servers. There LVM is used. Next we have ISCSI, which stands for Internet Smart Computers Systems Interface, and it allows to use storage over a network. So these are used in data centers and virtual machines. Next we have mirroring. I have already mentioned there RAID 1 is the mirroring technique. So in this case we have a duplicacy of data and 2 hard disks are used, so it takes more storage. We can recover our data, but it takes extra storage to store that data. Next we have stripping. So in stripping we split our data into multiple disks and we can recover, it increases the speed, but it also has a demerit that we cannot recover our data in case any of the disk fails. So next we will know that why these techniques are used. So the simple answer is that these techniques are used for a smarter combination, it is a smarter way how the physical disks will be combined to create a large storage, a big large storage. So this overcomes the fixed size physical disk which don't provide any redundancy, any fault tolerance, or any scalability or any remote access. So this storage virtualization and the techniques used overcomes all those demerits. So that's all from my side. Thank you.